Okay, so picking up where we were at the end of the first half of this recording, I hope you've had a little bit of a break between that one and this one. And if you haven't, give yourself a little bit of a break. The first one was abstract. We talked about some weird stuff about minds and intentionality and meaningfulness and experience, and a lot of things that might have sounded somewhat unscientific and more philosophical than scientific. And that was, of course, exactly the point, is that a lot of early psychology was driven by this idea that the goal is to try to study experience and to study consciousness and to study awareness. And what we found is that it's very difficult to justify having a scientific study of such things because of the complete lack of objectivity when it comes to being able to observe mind. And so what we end up moving on to next are, as we move a little bit forward in time to the early 20th century, we're going to look at psychology that tries to move away from being so highly mentalistic, right? So psychology without all of this mind stuff. But it doesn't seem maybe obvious. Why do we really want to do away with mind entirely in psychology? Well, maybe somebody is going to make such a claim. So I have this next slide here, psychology without intentions. And so we talk about unintentional behavior. That makes it sound as if it's accidental, but that's not what we mean here. We mean behavior that's not controlled. We're going to get rid of that controller. Remember, we were talking about Wundt's voluntarism, that he's talking about the will, this internal sense of agency that controls behavior. But one of the problems that we didn't even talk about in that first half with this kind of voluntaristic theory of mind is what is that inner sense of will or inner sense of agency? There's another criticism that sometimes is leveled at that kind of psychology, and it's called the problem of the homunculus. The homunculus is meant to be this kind of internal person, this internal agent who does all of your thinking and acting for you. The idea here is that in order to explain how a person thinks and acts, we appeal to some internal agent that does the thinking and acting. And that really, if you think about it, is not a satisfactory psychological theory, because it doesn't actually explain how thinking and acting happen. It just kind of relegates the explanation to something else, that something does it for you. But we might have to then turn around and think, well, how does the agent inside of you, how does the homunculus think and act? Does it have its own internal homunculus? And do we end up with this sort of infinite regress of a homunculi inside of homunculi inside of homunculi, sort of like an inception, right? An agent inside of an agent inside of an agent forever and ever. And that kind of circularity doesn't really help us to explain anything. It's not an explanation at all. So we want to get rid of controllers and internal senses of agencies, internal homunculi. Get rid of the will, maybe get rid of intentionality, meaningfulness, and all these things that are more philosophical. And what we're going to start doing here is we're going to start describing behavior more as a reflexive in a way, or even robotic. And be careful with that term, because we were just talking at the end of the first set of notes, the first half of chapter 1, about AIs. And machines that can perform behaviors that appear to be very complex. And we talked about how would we know if they are intelligent or not. And what we might conclude is that it doesn't really matter. If we could program a machine that behaves in a way that is very intelligent, we could perhaps program a robot that behaves and acts in various ways that are complex and unpredictable and variable in the exact same way that humans are, then maybe one answer to the question is we don't really care whether it has mind. We can't know that it has mind or awareness or consciousness, and that our goal is not to try to understand such things, but our goal would be simply to understand how it manages to act the way that it does. And that we would think that in order to explain how such actions occur, we don't have to invoke mind and consciousness and awareness and qualia and intentionality and all of these things. And if we can do that with a robot, we can maybe do that with an animal. We could explain animal behaviors without invoking minds and feelings. And if we can do that with an animal, we can do that with a human, perhaps. So here we have another approach to science. It's called reductionism. And so here what we're going to do is that all of these difficult, problematic philosophical ideas that we've been struggling with, we're going to simplify them. We're just simply going to say that we can get rid of all of that stuff and we can reduce the study down to simple behaviors. And so we end up with something like this. So what we're going to go into is, if you go back to that first slide in these notes, we talked about these three different ways of defining what psychology is all about. There's the psychology of experience, the psychology of interactions, and then process psychology. So here we're going to take an approach that does away with mind, but doesn't necessarily get rid of internal processes. But these internal processes have a little bit more of an objective definition. Some of this begins in philosophy, however, but it's a much more recent philosophy. It goes back to guys like John Locke here. So you may have heard of John Locke before. Amongst the many things that he's famous for is the idea that we're born a blank slate, that we have no innate knowledge. That's in contrast to Descartes, who we mentioned in the first half of the notes. So we were talking about his emphasis on mind-body dualism and free will and so forth. But he also believed that we have innate knowledge. And that's an old idea in philosophy that goes at least back to the Greeks, like Plato. But Locke says that we're born a blank slate. And that means that we have no knowledge at the time of our birth. And that all of the knowledge, and therefore all of the action, everything that's happening inside of our mind is really just the accumulation of experiences, which is just another way of saying that everything about us is learned. And once you define knowledge in this way, and once you define psychology in this way, you then you kind of have a roadmap for how to do psychology. Because if you say that everything about a human being can be explained by learning, what you now need is you need an explanation for how learning occurs. And you can develop a process to explain how learning occurs. You can develop a theory that says learning is a process that involves X, Y, and Z, some simple, concrete steps. And that makes it more objective because you can define those steps in terms of how learning occurs, if you're careful at least, without appealing to mind and intentionality and awareness, right? You don't need necessarily that kind of stuff. Now we're going to have to wait a little bit. We have a whole chapter on learning. We're going to get into the meat and potatoes of how that's supposed to happen, but I want you to kind of see how that fits in now with where we are when it comes to defining psychology. There's another philosophy here that is relevant to a psychology without intentionality, and that's called mind-body materialism. So if you remember with Descartes, he was a dualist. He suggested that the nature of mind is somehow completely the opposite of body, that mind is more about the soul and these spiritual kinds of things. Ideas are very non-physical, spiritual, ephemeral, whereas the body is a material substance. But following this kind of empiricist view of Locke, that everything is started with the observations, that's what empiricism means, is everything must be observed and then learned through observation, is the idea that we can explain it all in terms of just the body, matter, substance. In order to explain how learning occurs, again, we don't have to appeal to mind as some special entity. Perhaps we could just explain it in terms of brains and nervous systems. We could talk about neurons. And again, later chapters deal with the meat and potatoes of how brains work. But we could simply just say something about our physiology can explain all of this. And we no longer need all that weird special mental stuff. And that's called materialism. It's different than dualism. Another kind of synonym here is that dualism, the prefix dual implies there's two kinds of things, right? So the opposite of that would be monism, that there's only one kind of thing. And we don't need to go into all the philosophy, but the idea is that there's different kinds of monism, and one of them here is materialism, sometimes called physicalism. And what it basically is saying here is that there's really only one kind of reality, and that's a material or physical reality. Everything is a material substance. Everything's made of atoms, perhaps. And that's a very old idea, much older than our modern understanding of atoms, going again back to the Greeks, that they had these ideas that there would be some sort of fundamental substance of the universe. And they came up with the idea of an atom to describe the fundamental substance of the universe. And that idea has evolved quite drastically over the centuries since then. But the idea is everything is physical, everything is material substance. That includes what we think of as mind. Mind is no longer that special psyche, soul that Plato had envisioned, but rather it's atoms. It's activity of your cells in your brain. Again, later chapters, but we're going to talk about, when we get to the brain chapter, we're going to talk about neurons, and we're going to talk about action potentials, right? Gradients of activation of sodium and potassium ions moving in and out of neurons, not to mention also some calcium ions and various other stuff going on there. But that's all a physiological and a physical process. And so everything that we need to understand about mind is really something that can be expressed in terms of brain and body, physical stuff. That's another form of reductionism, right? Just taking all of that difficult, weird complexity of a mind and just getting rid of it and simplifying things down to much more concrete, simpler, mechanical explanations for how things might be working. And that's where we get to behaviorism as our next major school of thought. So we had talked before about some of that 1800s psychology that was very mentalistic, phenomenology and voluntarism, and Gestalt psychology, which was actually more in the 20th century, but still part of that legacy. But in the early 20th century, behaviorism comes around, and they're basically these behaviorists were saying all of that mentalistic stuff, it's not scientific. And if we want psychology to be scientific, we need to focus on observables, right? So again, back to what we said, objective observation, not subjective observation. So no more introspection where you can only observe your own mind. We already talked about the problem of other minds. I can't observe those. So what can I observe? Well, I can observe other people's behaviors. Hence why the name of this school of thought is called behaviorism, because that's what we're going to study. We're not going to study mind anymore. But we can also study something else. We can study a stimulus, because a stimulus is something that might trigger the response, and that's the behavior, right? So we'll call this SR psychology too. So the S arrow R refers here to a chain of events, right? The S causes the R, the S leads to the R. So we'll use that kind of symbol, S arrow R, to refer to what we call the SR chain. And the argument here is that the stimulus leads directly to the response. The stimulus could be anything, like I talked about doing reaction time studies in the first half of the notes that Wundt was doing. And I talked about the idea of a simple reaction time, like a light comes on, you got to press a button. And in an SR chain explanation of something like that, the light is the stimulus and the button presses the response. And the argument, of course, is that you go straight from the stimulus to the response, and there's nothing happening in between. What could be happening in between? Well, that's where that mentalistic stuff would come into play. That if I wanted to take a mentalistic explanation of that, what I would do is I would say that I visually perceive the light. And now I have this mentalistic awareness. Oh, I am seeing now this light. And I have all kinds of perceptual experiences about what is. And then I could tell myself, okay, now I have seen the light. I must press the button. And I will myself to press the button. I see I'm using all of these terminology from the phenomenologist and the voluntarist and all that kind of stuff. And then that will has to now cause some change in my brain that then triggers a signal that goes down from the brain to my finger and causes my finger to push the button. Whereas a behaviorist approach eliminates all of that extra stuff, and it just says that the nerve signal goes through the bright pathways and causes the button press without the mind, right? It's just a series of neural pathways, and that's basically it. So there's maybe many links in the chain, ultimately, between the stimulus and the response, but none of it involves mind or awareness or experience. We don't need to invoke those kinds of theoretical constructs, is one way to think about them, to explain how a response occurs in response to a stimulus. And in fact, there's another philosophical thing we can get into here that kind of justifies this kind of psychology. So I'm talking here about philosophy of science. What's that all about? Well, one of the things that we need to do when we start talking about whether something is a science or not, and I just said that the behaviorists wanted psychology to be scientific, and to them that meant getting rid of all of that weird abstract mind stuff. It raises an important question, which is how do we define science in the first place? And that's where the philosophy of science comes in, because philosophers of science will like to be able to say, okay, if something's going to call itself a science, what has it got to be? What characteristics must it have before we can say this is a science, that this other thing is not a science? What's the boundary there? And there's an old idea. It's called positivism. And the idea about positivism, the idea, why is it called that in the first place, right? So it's like if you've ever had a debate class, for example, you might know that there's a difference between making a positive argument versus a negative argument. A positive argument is you're saying, I say this is true. That's the positive claim. And the negative argument says, no, I say that's not true. But what you learn in debate is that the burden of proof falls on the person making the positive claim. If you're going to say X is true, you have to provide evidence of X. And that's where science comes in, because a scientist is going to say, I say X is true. And that means they have the burden of proof to provide evidence of X. Otherwise, we'd default to the position that X is not true. And what kind of evidence qualifies? Well, it has to be observable things. That's where the empiricism comes in. Things have to be observed. You have to have empirical data. That's observations. But again, it cannot be private. It can't be, well, I can see X, so therefore it's true, but none of you else can see X, right? If I say that some aspect of psychology is true because I've experienced it, but nobody else can experience it, that's not good enough, right? That's not good enough for any science. So if I say X is true, I need to be able to demonstrate it so that you and 10 other people can see it. And that's where behavior comes in, of course. Mind doesn't fit this definition of objective observability. So it's no longer, it's not positivistic. So behaviorism is an attempt to take psychology and to fit it within what we're going to call this positivist definition of science. So what we're saying here is that any statement that goes beyond what you have observed is potentially troubling, right? Because you can talk about what can be objectively observed, and you can say that this is empirical data and therefore it's a scientific observation. But once you start going beyond your observations, once you start making more general claims that go beyond observation, you perhaps get into what we call theories. Theories are general claims, right? The more descriptive general statements. Whereas this data is what you have described, what you have observed. Theories are more broad explanations that kind of go beyond the observation. And in psychology, we use these terms like attention or memory or perception, or what we talked about some in the first part, personality and intelligence. And those are things that really we can't observe. What we can observe, of course, is we can observe scores on a test, right? We can give someone an intelligence test and what we get is an IQ score. But there's a difference between the IQ score, which is an observable variable that we can measure, and the person's intelligence, which is that more abstract thing that exists inside of them. And what we worry about a lot is, of course, what's the exact relationship between that score and the IQ test and the actual intelligence. And one of the things that we kind of assume is that the IQ test is measuring something about the person, but whatever it is, maybe it's not a perfect measurement. But there is an important disconnect there. And the same applies to all of these psychological constructs. A psychological construct is basically a theoretical idea. We think that other people have memory systems inside of them. But how do we measure that? Again, I can introspect about my own memory, but that's not good enough. But I could give someone a memory test. I could simply give them a list of words to remember. I could let them study it for X number of minutes, and then I could take it away and ask them to write it all down, and they can do it. So I figured that's probably pretty good evidence that they remembered it, right? Because they can actually write down the words without having to look at the list. But what I have to be careful about distinguishing is the difference between what they have written down, which is the demonstration of what they remember, versus memory as an actual process happening inside of them. And what's important, and is what's especially true from the behaviorist perspective, is that the behaviorists were really, truly only interested in the response. They were not interested in trying to theorize about memory as a process happening inside a person. They were only interested in the response as an observable process, because that's scientific. That can be observed. I can observe the response. I can observe the fact that someone can write a list of words, but I can't observe what's happening inside of their mind. So the concept of memory remains more of a theoretical idea. We infer that memory as a system exists based on our observation that people can write down lists of words, right? Just like we infer that emotions exist because people exhibit facial expressions. They're smiling, and I say, you must be happy. But there's a difference between the smile and the happiness, right? The happiness remains a psychological construct. It's a theoretical idea that I use to explain smiling. But a behaviorist will not do that, right? A behaviorist will not talk about your happiness. A behaviorist will describe your facial expressions, but they will not talk about emotions as feelings. Again, getting into those feeling states, we're talking about experiential things. That takes us back to that older 19th century psychology. This seems to be a bit of a strange way of approaching psychology, right? To suggest that we're not even allowed to theorize about these kinds of things that seem obviously relevant to psychology, like attention, memory, perception, emotion, all of that stuff on the list there. But that's what behaviorists are all about, because what they're suggesting is that those things are not things you can observe. So what are we suggesting here? That we can't have theories in psychology? Can't have theories in any science? That doesn't seem right. So we need a new kind of philosophy of science, perhaps. So let's have another look here. So this idea that theories as statements that go beyond your observation and therefore are potentially problematic because they are might not be scientific, right? Because they're going beyond observation, leads us to some really bad places, because what this could possibly mean is that there's no way to explain our observations. We could just go around describing our observations and we can't explain them until we come up with a new kind of philosophy of science. Here it's called logical positivism. And what this is going to do for us is this is going to give us a set of criteria to establish a boundary now between a scientific theory and an unscientific theory. So in this case, what we have here is we have a way of defining science from non-science or from pseudoscience, because theoretical statements are where the problems come in. So we have all kinds of theories in psychology. In psychology, we have theories in all the sciences, right? We have theory of evolution. We have the theory of gravity, believe it or not, is a theory, right? Especially from the Einsteinian perspective, the theories about space-time, gravitational fields, and that sort of stuff. Because a lot of that stuff we can't even observe, really. Not in the direct objective way, right? Especially when it comes to quantum physics and trying to study subatomic particles and all that sort of stuff. So those remain more theoretical ideas because no one has really directly observed a subatomic particle, right? So we have to have logical positivism. We have to say that there's a way in which we can develop a theory to explain this kind of stuff that's different from just any old idea that someone might make up to explain it. So we start with this idea of a theory has to be logically consistent with the data. So that just might make some basic sense at face value to suggest that, for example, going back to the memory idea that I can give someone a list of words and they can look at it for a few minutes and then I take it away and they're able to write down the words. And then if I say that, well, that must mean that they have some way of storing those words inside of them. That statement seems to be logically consistent with the data. But if I were to say something else, like, I don't know, that that those words were transferred to some sort of writing. They were written down somewhere inside of their brains, and then that was kind of recreated at the point of writing it down. That's not necessarily logically consistent with our observations, right? And it certainly goes far beyond what we think is necessary to be able to explain this ability. So what's more important, though, is that a theory is testable. And this is where we start talking about this fancy phrase here, hypothetical deduction. So what we're talking about here is that theories, being general statements, must generate predictions. They must, and that's where deductive logic comes in. And a big part of why this is called logical positivism is that deductive logic is defined as reasoning from the general to the particular. So if the theory is a general statement, it must make particular predictions about specific situations, and those are called hypotheses. So hypotheses are derived from a theory using deductive logic. That's what you mean here by hypothetical deduction. And that means that if the theory actually generates a testable hypothesis, that it is verifiable, because you can test your hypothesis, which is where the importance of doing an experiment comes in. So if I start to theorize that memory is something that people have, then that might make me think, well, if that's true, I should be able to predict that people can remember other things besides lists of words. And I can find ways to test that, and then therefore set about verifying my hypothesis. And I can continue to do that and provide additional evidence verifying the idea that people actually possess memory. Although there's another variant here, which is that some philosophers have argued that verification by itself is not really good enough to provide us with a way of being really sure that this theory is true in a scientific sense. So the argument here is that what's better is falsification. The idea is that it's never truly possible to prove a theory true, but it is possible to prove a theory false, and that really should be the goal. And the idea is that if a theory doesn't make any way in which you can prove it false, then it's not really scientific. The ultimate classic example of a unscientific theory in psychology, you might be guessing, is Freud. We're not going to have a lot to say about Freud in this class because Freud is bunk. Freud has very little relevance to modern experimental psychology. When we study attention and memory and perception and motivation and emotion and all those things, we don't use Freudian ideas because it's not scientific. And it has never really been verified, for starters, but it is certainly not falsifiable. That's the major claim here. Let's think of an example. Freud had some strange things to say about child development. And he said, for example, that when children are going through their toilet training years, when they're 2 to 3 years old, that this is an important time of life when they're learning to deal with right and wrong and the formation of their superego. And whether parents are overly strict in their discipline, whether it's with the toilet training part of discipline or just any of the disciplinary stuff that they're doing, if the parents are overly strict, this might cause a child to develop what's called the anal retentive personality type, right? And the idea is that the anal retentive personality is the kind of person where you absorb all of that strict discipline and you now have a really strong superego with a strong sense of self-discipline. And that means you're neat and tidy, you're always on time and prompt for your appointments, everything has to be in its place, right? You're a highly organized person. But that sounds like a prediction, right? If the parents are strict, then the child ends up being anal retentive. So you have an if-then kind of statement that's a prediction. Except that's not quite what Freud said, because Freud also raised the possibility that if the parents are overly strict with toilet training, the child might also become the anal expulsive type. And the anal expulsive personality type is the exact opposite of the anal retentive. It's a person who is sloppy and disorganized and messy. So which is it? Does overly strict parenting lead to anal retentiveness, or does it lead to anal expulsiveness? And Freud makes zero claims about that. Rather, how Freudian theory works is more of a backwards explanation. So you start with an adult who may have an anal retentive personality type, and then you psychoanalyze them. And in your psychoanalysis, your conclusion is, oh, your parents were too strict with their toilet training, and that's why you have this personality. And then in contrast, you might have a different adult who has the anal expulsive personality type, and you psychoanalyze them, and you might come to the exact same conclusion. Oh, your parents were too strict. That's not scientific reasoning, right? That's not deduction. It's not hypothesis testing. It's a theory that can never be falsified, because what does strict parenting do to a child? Well, it could be this outcome, or it could be this other outcome. So strict toilet training is not a testable idea, because there's no way to falsify it, right? It's going to do one thing or another thing. And in some cases, it might do nothing at all. And the theory can be twisted to account for any possible outcome. And whether it causes one personality or the exact opposite personality or something in between or nothing at all, there's always a way for the theory to be wrangled and twisted to explain those outcomes. And if that's the possibility that it can just be so powerful that it explains everything, that's really not explaining anything, right? And it's never falsifiable. It's therefore not testable, and it's not scientific. And so we abandon that. One of the things that we can see here is that with logical positivism giving us the ability to generate theories, as long as they are testable, as long as they are verifiable and especially falsifiable, that we can start having theories in psychology so that we can then go beyond what the behaviorists were doing, right? Because the behaviorists were, again, trying to get rid of all of the internal processes like memory and reasoning and attention and perception, and just replace it with behaviors. Because they said we can't study those internal processes. But cognitive psychology, which arose in the mid-20th century, basically started to say behaviorism is never going to succeed in explaining some of the things that are a little more complex about people. Language perhaps being a really good example of that, because language is a fairly complex behavior. And when we try to take this reductionistic, simplistic way of analyzing language that the behaviorists are trying to do, it really fails to provide a good, satisfactory explanation of it, especially when it comes to things like when children are learning language when they're 3 years old, because behaviorism tends to focus on things like imitation. And the idea is that children learn language through imitation. But when you hear a 3-year-old say some fairly complex sentence that they have probably never heard before, you start to see how it seems that children's abilities kind of exceed their experience, right? It goes beyond what they have been exposed to. It goes beyond mimicking and imitation. And therefore, the only way to explain it is to suggest that they have learned some kind of language process inside of them. And that now they're able to take that and they're able to generate completely novel sentences, saying things they've never heard before, saying things that perhaps no one has ever said before. At least in terms of strings of words together, that's completely novel. And so we have to go beyond that. We have to start invoking some kind of psychological constructs, like internal language generating systems, internal grammar systems. And so in the mid-20th century, that's what happens, is all of this research just totally blows up, right? We've got all of this research on memory in the 1960s and 70s, a lot of perceptual research in the 50s, 60s, and 70s. Of course, that continues on today. We have a lot of research on attention right now as a really popular area. For example, we talk a lot about things like distracted driving. We worry about people who are driving while using various forms of technology. Initially, it was just cell phones, simple little cell phones, but now we've got smartphones and screens and all kinds of displays and in-car technologies, GPS screens and all this sort of stuff. And we worry about people's abilities to divide their attention across many different stimuli, right? Paying attention to screens and plus what your car is doing and what the other cars all around you on the road are doing. We need to understand human attention. And so we have a ton of research going on in that particular area. And then kind of some of the newer stuff that we'll add on to that will be things like the neuroscience. As we said before, there's a materialism happening here from the philosophical side that we can explain all of this stuff ultimately by saying it's got to be happening somewhere in the brain. perception is happening somewhere in the brain, memory is happening in the brain, attention is happening in the brain, so is reasoning and problem solving and language. There must be a part of the brain that's dedicated to each one of these processes. So we want to understand how the processes work from a psychological perspective, but we also want to understand how they work from a physiological perspective. So this is where we start using the neuroscience methods. I mentioned in the first half of the notes things like functional MRI, where that's a form of brain imaging, where we can just look to see what a part of the brain is active during the task. And there's other functional tests that we can use besides MRI. There's things called near infrared spectroscopy, and that's where you can put a headband on someone, and it kind of beams infrared light through their skull, and that infrared light bounces off the brain. In fact, it bounces off of the blood. And what it's doing is that in any part of the brain that's receiving a lot of activation because of a task that we're engaging in, the neurons in that part of the brain require more energy because they're active, and blood flows to that part of the brain. And that's why MRI even works the way it does as well, because iron in the blood becomes magnetized in the MRI scanner. But the infrared light in this other technology will reflect off of the red blood and the oxygenated blood. And so then the sensors in the cap that you're wearing, or the headband that you're wearing, can detect variations in the blood flow as a result of that. Or we can record the electrical activity of the neurons in the brain. So again, we'll talk later about how neurons work, but there's because of the positive and negatively charged ions that are moving around in and out of the neurons, there are electrical impulses that can be detected. And that's what an EEG does, is it picks up the electrical activity of the cells in the brain. And so you can determine what kinds of patterns of electrical activity are happening in the brain and how they change in response to a stimulus. And then so that we can link that with various forms of, if I give someone a memory test and I can see certain changes in their EEG, I can understand exactly what memory is doing to the parts of their brain. That kind of wraps up our little section on the theoretical side of psychology and the philosophical side of psychology, and the history of how those different ways of thinking have kind of got us to where we are. And so that last slide with cognitive psychology and cognitive neuroscience that is where we are as a field pretty much. But there's one little tag that I want to have at the end of these notes here. So we're going to go into that here in a second. I always find that there's some value, I think, in doing this, because what we're doing in the next set of slides is talking about careers in psychology. And so it's a bit more concrete, less intellectual sounding and all that sort of stuff. But I find that a lot of people don't know about all this stuff. We think of psychology as just something where, oh, you get this degree in psychology, then you go off to become some sort of a therapist. And that certainly is part of the many pathways that are out there, but there are more than that. And I want to talk about that. So that you know, in case you might be a psychology major, this may be helpful for you to understand exactly what some of your options are. But even if you're not a psychology major, you can have a broader view over all of this kind of stuff and understand what's going on. So let's talk about the obvious one first. It's called clinical psychology, because it deals with clinical issues. Clinical issues meaning someone has something wrong with them. I don't want to say it that way, so I take that back. But they have a problem. They have what we might call a psychological disorder, and sometimes we might call it a mental illness. But there's something that's causing them to feel that they need help in some way. So if you have a bachelor's degree at UCF, that would be a bachelor's of science. Psychology is part of the College of Sciences, so it's a Bachelor of Science degree. And in other universities, it might be part of the College of Arts and Humanities, and therefore students might get a Bachelor of Arts instead of a Bachelor of Science. Some schools offer both. So if you can get a BA in psychology at a school, but if you take a few extra science classes or advanced methods classes, you can get a BS instead. But I'll focus more on the BS since that's what we have at UCF. There's actually not a lot you can do in clinical psychology with a Bachelor of Science degree, but you can do things like you can become a psych tech. So that means you can work in various hospital settings or other medical settings to do things like, just assist with patient care, to maybe do some intake meaning that when a person comes in, you interview them, you get some basic information from them, get them all set up. Or you can do something called behavior analysis, applied behavior analysis. There's specialized certificates that you probably have to get in addition to the bachelor's degree, but you don't have to go get a whole separate degree, but really more just a certification. But this is a very common way of treating people who are on the autistic spectrum, is to kind of break down their behaviors into kind of what are the problem behaviors, and you work on changing those behaviors. That's what it's kind of an applied behaviorism. It uses principles of behaviorism like classical conditioning or operant conditioning, which we'll talk about in the learning chapter, to engage in what's called behavior modification. And you can kind of get rid of some of the undesirable, sometimes repetitive, self-injurious behaviors we might see in especially young children with autism, and then increase the more desirable behaviors. Now, with a master's degree, whether that's a Master of Science or a Master of Arts, you can oftentimes get a master's degree in clinical psychology or some form of counseling or counselor education. You can work as a school psychologist or a school counselor. Or you can do kind of limited counseling in a very similar way to someone who gets a master's in social work and become a licensed clinical social worker. You can kind of provide group therapy or specialized therapies in these kinds of settings. But then there are these doctoral degrees. So the PsyD means a doctor of psychology. The PhD, the PH refers to philosophy there. So when you get a PhD, you're really a doctor of philosophy. The PhD is the kind of the classic degree. The PsyD is a much newer degree. The idea is that typically when you get a PhD, the degree is focused on research training. And there was a time in the mid-20th century when people who wanted to become clinical psychologists felt that the PhD was inappropriate for them because they didn't really want to do research as much as they wanted to become a trained clinical psychologist. And so the PsyD focuses more on learning the trade of clinical therapies, less so than research. So the PsyD tends to be that highly specialized kind of degree. There's a few of those around. But PhDs are actually, they offer the same kind of stuff, because a PhD, despite the fact that I said there's a big emphasis on learning to do research and learning to conduct academic research, scientific research, typically in a clinical kind of setting. So the idea is that if you're a clinical psychologist with a PhD, in addition to receiving the appropriate training to deliver therapies and to treat people with their psychological problems, you're also trained to be able to do research in clinical areas. So if you want to do research on the nature of things like let's do some research in schizophrenia, understand what it is. Let's do some research on bipolar disorder or major depression. What is it? How can we best treat it? Research on ADHD. What is it? How can we best treat it? That's where clinical psychology researchers come in. So the difference here is, when it comes to getting a job, if you have a PsyD, your job options are pretty much constrained to becoming a practicing therapist, whether it's in a private practice setting or a hospital setting or something like that, but it's pretty much limited to that. Whereas if you have a PhD, your options are a little bit broader, because while you can work in those same private practice or hospital clinical settings, you can also work as a professor. That's usually where most research happens. You can work in perhaps industry or in military settings doing research, but quite often academic research means research done by professors in university settings. Raising my hand here, that's what I am. I am not a clinical psychologist. However, we'll get to what I am right here, actually. So experimental psychology. So this is a lot of the stuff we've been talking about, and pretty much almost everything that's in your book and what we're going to talk about in this class is really about what experimental psychologists have discovered. So when I say you're an experimental psychologist, what I mean is that you're a psychologist who does research. You're a psychologist who conducts experiments, who conducts psychological research on animals or people, to basically understand human behavior. You're working as a scientist. There are master's degrees in this field, so you can get an MS in this, but there are very few of that kind of thing. And because the master's degree doesn't really give you the detailed level of expertise, in research that the PhD does, then there's kind of limits to how much you can really do work in that with that kind of degree. But if you get a PhD in experimental psychology, then you can become a researcher. And as I mentioned, you can do some research maybe in industry or military settings, but the kind of the vast majority of people with PhDs who work as researchers become psychology professors. And the job description there is teach some classes. And the main thing though, the main focus of your job description is to do the research, right? You have to conduct psychological research, publish that research, get grants, do all the stuff you're supposed to do as a psychology professor, as a researcher, and as a scientist. So when we talk about memory stuff, right? Everything we know about memory, which we'll cover in one of the chapters here, that's research done by experimental psychologists, right? Got a chapter on perception coming up, chapter 5, right? Again, that's my area. I'm an experimental psychologist who studies sensation and perception. My degree area was technically called sensory psychology. I study the visual control of reaching. And so vision for depth perception and how we move around and interact with the world and reach out and pick up objects. That's my area. Right? It's pure, basic psychological research on how visual systems of the brain work, how visual perception itself works, and how the control of our arms and our legs works as well. How we use visual information to get my hand where I want it to be to reach out and pick up an object. How do I know where the object is? How do I know where the hand is? And how do I get those two things to come together when you're picking something up? And then there's something else here. So I said that was called basic research. There's a difference between what we'll call basic research and applied research. Basic research is when you're doing research just to answer some really basic questions. That is answering questions for the sake of knowledge, right? I just want to know, how does it work? Applied research is much more about solving a specific kind of problem. For example, when I was using the talking about distracted driving before, I could study attention merely for the process of just trying to understand attention because I want to know. That's basic research. But if I want to understand attention so that I can solve a problem, like how can I address issues related to distracted driving, that's applied research. And so when you might even hear, for example, about research that suggests that people who are driving with a smartphone in their hand are distracted, and that causes them to be maybe impaired in their driving to the extent of a person with a blood alcohol level of point whatever, I don't know. Right, so there's some equivalency there in terms of the degree of distraction or degree of impairment in your driving between a cell phone and intoxication. That kind of research is done by applied psychologists, right? And we actually do a lot of applied psychology research here at UCF. We have driving simulators on the 3rd floor of the psychology building. And we can put people in the driving simulators and do various things and give them secondary tasks to do, like an actual cell phone conversation. And we can measure their errors and their mistakes and various changes in their driving skills. We also have a lot of virtual reality setups in the psychology building, where we can put people into various situations where we can measure their performance while they perform some task and look to, figure out how can we manage that, right? So 2 major kinds of applied psychology, and we have a doctoral program in both of these and a master's program in one of them, the industrial organizational. We have a master's and a PhD. And this is one of the more popular choices in graduate education for psychology, probably because it's the highest paying. Someone with a master's degree in industrial organizational, or just IO for short, can typically start around $70,000, $80,000, $90,000 a year. PhD, a little bit more, and probably at least $100,000 to start. Oftentimes it's because you can work in industry more so than in academia. Academics are paid less, right? The university professors are not paid as much as the people who go off into work in industry to do that. So if you have a degree in IO psychology and you work in industry, you're going to work in personnel, right? That tends to be the focus of IO psychology. It tends to be on things like how do you, the organizational side of organizational psychology, IO psychology, focuses on things like how do we define the organizational structure of a company, and who should be assigned to what kinds of layers or jobs within the organizational structure, and what makes a person good at this kind of job. So this helps you understand things like why it's often fairly common to take a personality survey before you before you ever start a job, because they want to figure out what are you best suited to be able to do. And so IO psychologists have figured out kind of what's the best way to identify a good person for a particular job, and what's the best way to select them, what's the best way to train them, what's the best way to incentivize them to work, right? So all of these reward structures that different kinds of companies might have to incentivize higher productivity. That's why these jobs are high paying, because if you can do something like that to create a particular incentive program to improve productivity, companies make extra hundreds of millions of dollars, so they pay people a lot of money to be able to come up with these kinds of systems. Human factors, which is more closer to the kind of stuff that I do, is there's an overlap between my sensory kind of stuff and human factors psychology. Human factors tends to focus on the interaction with technology. So when people use technology, so that distracted driving research that I talked about, that's a form of human technology interaction. And that's the job of human factor psychologists. Using cell phones themselves, right? How do we define a smartphone and the displays and where all of the icons and stuff, all of that stuff, and how's it all organized? With the Windows operating system or the Mac iOS operating system, how it's all organized. That's the job of human factor psychologists. In fact, I have a former colleague who is the director of human factors at Microsoft, and he makes a ton of money, and because he's the director at this point by now. But he helped design the Microsoft HoloLens, right? The augmented reality headset that they have. That's not actually a very popular commercial product quite yet. But the idea is, you create these kinds of specialized technologies that people will use, and you have to be able to design them to make them usable, easier to use, and understandable for people to use. So we have to figure out, for example, even if something as really basic as designing a car, how does the steering wheel work? Does it make sense? Because we use a steering wheel to steer the car, and that's kind of an obvious thing, but there could be other ways to steer a car. There could be other kinds of controllers that would work. And in the history of cars, there were, in fact, other ways to steer the wheels of the car, but we settled on the steering wheel because it's the most intuitive. So what this means is that we have to do things like we have to take into account basic human tendencies to think about things a certain way. There are limitations, for example, on our abilities to see and to hear and to remember, right? There's only so much that we can keep active in our mind. And so when it comes to interacting with any kind of technology, we don't want to ask people to do more than they are able to do. So you don't want to present too much information to a person driving a car, because that's overloading. And of course, that explains why cell phones are distracting, because you start giving them too much information. And now you have to pay attention to the conversation as well as all the stuff happening with your car. All right, that kind of wraps up our first chapter here. So absorb all of that, and we'll come back for chapter 2.